Welcome to Vesta, visualizing explosive atmosphere scenarios and tracking barrier assurance using the bow tie technique. Vesta aims to go beyond familiar fire and explosion risk assessments to provide a framework for ongoing assurance. It helps frontline personnel recognize and respect measures that must remain present and performing to manage flammable atmospheres, control ignition sources, and mitigate the effects. This simple representation summarizes the major receptors that could be impacted by an uncontrolled ignition of a flammable atmosphere. A fire or explosion may occur when a credible, competent, or effective ignition source coincides with a flammable substance, e.g. gas, vapor, mist or dust, mixed with air. If an ignition occurs, the effects may be reduced by suppressing or venting the explosion, or the equipment or structure is designed to be capable of withstanding the impact. Reducing the access to, and/or occupancy within, a hazardous area may contribute to the risk reduction. The impact on fixed plant or equipment is not reduced by access or occupancy, unless they are mobile and only occasionally in the hazardous area. Combustion products, e.g. burning embers, may become an ignition source to upstream or downstream systems if the explosion cannot be suppressed or isolated. A list of potential ignition sources has been developed from EN 1127 Part 1. These threats are hot surfaces, naked flames or hot gases, for example from welding, mechanically generated sparks, typically friction, electrical apparatus which may create sparks, stray electric currents, static discharges, lightning strikes, radio frequency waves, radiation in the spectral range of electromagnetic waves, ionizing radiation, ultrasonic sound waves, compression and shock waves, exothermic reactions including self-ignition of dusts. Each ignition source will have their own controls, which typically involve components which are designed, constructed, installed and maintained in accordance with relevant standards. Other controls may rely on the physical properties of the materials being processed. Containing the energy source or isolating it from the flammable atmosphere may also be an appropriate control. Sensitive materials, which have the potential to auto-ignite, should be stored or processed under benign conditions. The likelihood of an ignition source occurring or being present can be categorized using a simple relative frequency ranking, according to the conditions that would create the threat. The effectiveness of each prevention control can also be relatively ranked, based on evidence, experience, or judgment. Not all barriers will be applicable, depending on the age or design of the facility, and the effectiveness of some barriers may not be known, which should be a cause for concern. The aggregate likelihood of a credible and effective ignition source, combined with the potential for a flammable atmosphere, indicates the possibility of an explosion. The effectiveness of the mitigation measures are also relatively ranked in the same way as the prevention controls. The relative severity of the effects on personnel or the assets can be used to determine the risk target. The combination of threat frequency, prevention effectiveness, flammable atmosphere potential, mitigation effectiveness, and consequence severity can be used to qualitatively or, with good data, quantitatively predict the residual risk. This is compared to the risk target to determine if the risk is acceptable or not. Showing all the possible ignition sources and associated prevention or control measures, plus all the potential mitigation measures, gives a holistic view of each scenario and can be used to demonstrate that all aspects have been considered. Using advanced filtering within Bow Tie XP, the scenario can be condensed into a focused view, showing only the credible or applicable elements. To support the selection of barrier effectiveness, the assessment may consider the key components that sustain it, e.g., how good are the associated people, processes, and plant. The personnel who ensure the presence and performance of the barriers must themselves perform effectively. The paperwork which guides the planned and unplanned barrier tasks must be accurate and accessible. Barriers must be well looked after to ensure they are fit for duty or service. The potential for a flammable atmosphere may already be known as part of a hazardous area classification. Otherwise, it may be predicted using simple principles, such as the grade of release and the effectiveness and availability of ventilation. This example is a modified EN 60079 Part 10.1 approach. However, alternative approaches may be used, according to your jurisdiction or company standards. Using bow tie chaining and relationship models in Bow Tie XP, the impact on connected systems is more apparent and can be properly evaluated and addressed. Visualizing explosion risk assessments provides a platform for ongoing assurance, and although the method is the same as conventional tabular assessments, bow ties provide a more easily understood and therefore manageable scenario. Simple color coding of ignition frequencies, barrier effectiveness, flammable atmosphere potential, consequence severity, and explosion risks provides an accessible overview to a wide range of stakeholders, including regulators, who require reassurance that you are and remain in control. Qualifying or quantifying the components allows sensitivity analysis of the assessment to be conducted. For example, how does the risk change if I change this category or value? Similarly, what is my current risk because my barrier effectiveness has decreased, or my occupancy has increased, since the previous or original assessment? Representing the fire or explosion scenario visually provides context and highlights the criticality of barriers so that the impact of any planned or unplanned changes to them can be properly evaluated.